Welcome. So here we go. I have log base 2 of r plus 2 log of 2 of log base 2 of 5 equals 0. And so I have a couple logarithms. And so to solve this, I gotta see what I can do when I have multiple logarithms to use my properties of logarithms to try to see if I can condense this down to one single logarithm. Because if I can condense it down to one logarithm or set the logarithms equal to each other, then what I can do is simply isolate them. So therefore, it is I can use then my other properties of logarithms to solve. So what I can use here is I notice that I have a couple things. I have a number that's being multiplied by my logarithm. And if you remember, when we have a number that's multiplied by a logarithm, and it doesn't matter what it is, that means we can write, by using the power rule of logarithms, we can rewrite that at log base n of n raised to the p power. So that's the first thing I'm going to want to do here, is I'm going to want to rewrite this by using the power rule of logarithms. So now I say log base 2 of 5 squared. All right, so that's the first thing I'm going to want to do, equals 0. And the reason why I want to do that is I can't apply the product rule of logarithms until I've rewritten that back into the exponent, because then it's not the single logarithm, it's not going to be 2 times the logarithm. You're only multiplying 2 times this logarithm, and that 2 is the same thing as having that 5 squared. But now I can use my product of logarithm, which states if I have the addition of 2 logarithms with exactly the same base, I can rewrite them as a product of one logarithm, which we're evaluating for. So I can rewrite this as log base 2 of 5 squared is 25 times r. So I can rewrite this as the product now equal to 0. So now to solve, the reason why it's so helpful to go from 2 logarithms now to 1 logarithm is because now what I can do is I can rewrite my logarithm in exponential form to now solve for r. So I can kind of get rid of that log to solve for it. So rewriting this in exponential form, remember my base is going to remain exactly the same. So now I have r raised to the 0 power equals 25r. Well, any value raised to the 0 power we know is going to equal 1, which is now equal to 25r. So therefore, divide by 25 on both sides, and we can say r equals 1 over 25. So there you go, ladies and gentlemen. That is how you evaluate for a logarithm by using the product property of logarithms. Thanks.